Welcome to the data center as a unit of compute. This is a presentation I was given at NVIDIA's Global Technology Conference on March 17th, 2025. Thank you to IDC and the info brief we collaborated on with the take on AI workload growth and energy demands. So I'll build on that to explore how we at Vertiv see the data center evolving. It's not a separate pieces, but as a unified system delivering compute capacity. Because AI is driving a holistic rethink. We've been working with NVIDIA, scaling from hundreds of kilowatts to megawatts to gigawatts for token production. So think racks hitting several hundred kilowatts and clusters at 100 megawatt and more. Interestingly, the other day I met with a large European-based AI provider. They're focused on sovereign AI, and they're pushing this multi-megawatt AI factory, the largest of its kind in Europe. Now, the interesting part there in the conversation was they've never built a data center before, never designed one, they never operated one before. They're expecting compute, power, and cooling as one seamless unit. And that's just a complete paradigm shift for us. So that's the focus of this presentation. So let's unpack the trends steering the shift. So these are redefining infrastructure and infrastructure design and deliver. Number one, exponential data. So as IDC in their info brief, they noted 84% of tech leaders see Gen AI as a core workload. So that's petabytes daily that's being generated. So companies like, healthcare firm Mayo Clinic, they're drowning in patient data, needing scalable systems. That takes accelerated computing. That's what's required in order to do this. But think of NVIDIA's Blackwell GPUs. They deliver 35 times more compute. And that's what's driving this 20 kilowatt, 40 kilowatt, 80 kilowatt. And we're already at 130 kilowatt today, jumping to perhaps 500 kilowatts and beyond. Density that demands tight power and cooling sync. And that requires unit of compute. This is key. Companies want plug and play, just like this sovereign AI customer I talked about. Compute, power, cooling is one. So kind of think Tesla's autonomous driving hubs, the whole ecosystem around that. It's about performance and not the parts. You need technology partnership for this. Collaboration fuels it. And we've been working with NVIDIA for over 5 years now. Our work aligns power, thermal, and controls roadmap with them. And out of it comes liquid cooling, pre-engineered systems, reference designs, all of this, slashing deployment times. So as Einstein said, a measure of intelligence is the ability to change, and we're certainly adapting with it. So what does it all mean? What's the impact here? These 6 points here, they really tie to the IDC's info brief on 23.5% growth in energy, compound annual growth rate, and this 108 gigawatts by 2028. And that's rooted in real world shifts like NVIDIA's speed to token focus and enterprise AI adoption. So we start with potential for accelerated innovation. AI factories are innovating fast. NVIDIA, they're eyeing this gigawatt cluster because industries like healthcare, for instance, they're using AI for drug discovery. You take Moderna's mRNA models, they cut years off the timelines using AI. There's short versus long-term resource demands. So in the short term, we see some efficiency trends, and some of them bigger than others. But in the long term, we still need a focus on that, because you look at the financial sector like a JP Morgan Chase, they're scaling AI for trading, and they're spiking their demand over time. So the underlying infrastructure and driving that long-term efficiency of that has compounding effect on the rest of them. Lean training spurs more demand. This is a good thing. So lean training invites new players, which is great. These players could be in sports analytics, talent scouting, mental health, beekeeping, but probably more prominently, you look at retail has the ability to jump in, like a Walmart's AI for inventory optimization that needs dedicated compute units and just multiplies its usage. Now, inference is still the big driver, by far the biggest driver in this. Now, training is loud, but inference really dominates. Training is loud because of the headlines that it catches from the sheer scale of the investments and the sizes of some of these facilities. But inferencing is where the outcomes are. That's where it's being monetized. Google search AI handles billions of queries daily. Compute runs nonstop, dwarfing training's footprint. You go from data limited to compute limited. So the self-generated data kind of flips the bottleneck to compute capacity. You take Tesla in automotive, they're training on endless road data streams. So it's like building a highway. You don't just pay for today's traffic. You plan lanes for the rush hour 5 years out. So infrastructure needs to have foresight, ready for rack densities of hundreds of kilowatts and beyond that. Now, is that a likely market overreaction, both to capacity, perhaps, but probably not if we sort of look at it. Efficiency gains often shocks the market. People assume slower growth when we find efficiencies in it, not this sprint that we're looking at. We did expect some compute leaps, but probably not this soon and not this big. We've seen a few big announcements over the past few months here that would lead us to this, but it is so overwhelmingly large. You take Amazon's AWS AI expansion, cheaper compute doesn't curb demand, it unleashes a flood of adoption. You think healthcare diagnostics to autonomous fleets, faster than anyone has braced for. And it really takes me to Jevons paradox. Efficiency doesn't cut consumption, it supercharges it. You take the iPhone, you launched at $499 in 2007. That's about $750 today, adjusted for inflation. That had a 2-megapixel camera and no app store. Also, no buttons. Now, fast forward, same phone, same appliance, $899 or $799. It has a 48-megapixel lens on it, millions of apps with it, and a whole host of other features and capabilities. So economies of scale slashed cost per feature, better chips, sharper screens, but billions have been sold because we all started snapping photos, streaming, and obviously my own solid contribution to TikTok scrolling. So AI is mirroring this. So we need speed. We don't need a breather. NVIDIA and Vertiv systems shrink deployment time for these 100-megawatt AI factories, and healthcare firms roll out diagnostics faster. Compute gets cheaper, usage explodes, more models, more queries, more gigawatts. So IDC's in their brief, 915 terawatt hours by 2028. That's Jevons doing its thing. So here's an interesting one. So the enterprise revival. Enterprises are waking up to a seismic shift because it's not just about adopting AI. It's really about owning it. This sovereign AI provider that I talked about, they're targeting regulated sectors, government, defense, banking, where data control it's non-negotiable, it's table stakes. But this goes way beyond that. Tesla's guarding autonomous driving IP, years of road data distilled into models. Goldman Sachs locks down trading algorithms that move markets. Pfizer, they're protecting drug discovery breakthroughs. And why? Because you feed your AI data into these models, the IP is gone. Legally, it's theirs. It's no longer yours. So competitors can extract your edge from a single query. And that's a wake-up call. So compute units, power, cooling, GPUs fused into one, flips the script on this here. They let enterprises keep AI in-house, secure, auditable, and sovereign. So back to IDC's 84% stat, tech leaders seeing Gen AI as a core workload shows this isn't fringe, it's the mainstream. Now, if we look at training is a launch pad, and the numbers are just jaw-dropping. The industry sunk $200 billion into AI infrastructure, and likely closer to $300 billion as we speak, with $1 trillion slated by 2030. Think about that. The U.S. interstate highway system costs $114 billion over 35 years in today's dollars, and that's roads that reshape commerce culture. Wiring the internet's backbone in the late 90s cost us $1.5 trillion in telecom and tech build out. AI's spend is on that scale, but it's faster and it's fierce. Finance giants, they're pouring funds into AI factories at just a breathtaking scale. 100 megawatt clusters today, gigawatts on the horizon. And why? It's all about that first token. The moment a model goes live, delivered at breakneck speed. It's not just an investment, it's a race to redefine what's possible. But it's not just cash and investments, it's payoff. And history shows how big this can get. Cisco's CEO pegs AI data center revenue at about $5 or $10 billion already. Early days, but think electrification in the 1920s. The U.S. utilities, they hit $1 billion in annual revenue, about $15 billion in today's money. As factories, they plugged in and sparking this industrial revolution. Think of smartphones. Apple's iPhone, they raked in $10 billion in 2008, its first year out, the first full year out. And then it just exploded as apps took off. And AI is on that cusp. Yet 80% of enterprise data isn't cloud ready. It's locked in silos, like unmined coal before power grids. Compute units bridge that gap, turning raw data into inference gold, real-time insights, billions of queries daily. Ours in NVIDIA's gigawatt vision, these automotive AI hubs like Tesla self-driving fleets, they're paving the way. This is value unlocking at scale, and it's just starting. So accelerated computing drives this. That's why we're here. Densities are soaring, and it's moved us from what we knew as a 20 kilowatt rack that was pretty high dense to 40 kilowatts to 80 kilowatts to now 130 kilowatts and promising to go even further than that. Proximity is just really key in accelerated compute because of the access to memory that it requires and because of the parallel nature of it. It's not just density for density's sake, but because that's how we unlock 35 times more compute capacity. And that leads to new technologies, high voltage power distribution, liquid cooling, lots of gallons per minute, intense and accelerating. So we don't know the peak of pace, but we just know it's rapid. And there's plenty of technology evolution and innovation going on right now, both with NVIDIA and with Vertiv, that's going to help us curb some of this here. But infrastructure must be ready, sized correctly, pre-engineered, synced together, and consider power and cooling together. That's the unit of computer work. So disparate systems really pose challenges when it comes to this. And the speed at which we got to do this here, there's some big hurdles in this. Power availability. You take Silicon Valley, PG&Es, they're facing 3.5 gigawatts of new data center demand by 2028. There's like an 800 megawatt project in Hayward. That's a Miami size, like Miami City size power requirement. The permitting and grid upgrades, they lag years behind and local capacity is tapped out. We need new methods. We need renewable energy, grid interaction, microgrids, battery energy storage systems, and perhaps nuclear, small modular reactors. It's just critical to meet this. Another interesting one is asynchronous upgrades. You think of swapping out, because you will do refreshes in these AI factories. Swapping out 130 kilowatt rack while the other 9/10 stays live is crucial because of the sheer scale of the operation. You cannot take the whole thing down. Densification, several hundreds kilowatts, strain pipes and just physics. The circular economy in this, it's a lot of heat that's being rejected here. And so heat reuse at scale, like 10 to 15% recovery goals today, high 60s in the future, perhaps. Customers need end-to-end solutions, not just parts. So system thinking is the answer. Financial firms, as a customer, they don't just want a chiller or a UPS or a rack PDU. They want chunks of compute online. NVIDIA's AI factories, they're computers, and that's what we're part of as Vertiv. Power, cooling, compute is one. Prefabricated systems like our 2 megawatt modules, they cut deployment time. It's outcomes over components. So our NVIDIA partnership really brings us to life. We've been working with NVIDIA now for almost 5 years. Really fun, interesting journey. And we have been, and we continue to align on and co-engineer the power, thermal, and controls roadmaps here. Power distribution, modules, reference designs, liquid cooling for use several hundred kilowatts per rack. And that delivers these joint designs in compute as a unit. We add to that the full powertrain and thermal chain to it, along with 4,000 plus field techs. We could deploy and adapt globally, turning disparate systems into seamless capacity. So what's the win? It's infrastructure as a unit of compute. You look on the left-hand side of the slide and bears some resemblance to a printed circuit board there. That's power, cooling, and IT services all fused together, delivering up to 20% more energy efficiency, 30% more space efficiency, deployed in half the time, at 25% total cost of ownership savings. The key here is also it handles dynamic AI loads. Think of it as it's like a pit crew where the car zips in for a pit stop and everything is in sync to refill, change tires, tune the car. Too much, it's wasted. Too little, the race is lost. It's the same thing for GPUs, predicting power and cooling ahead. So from gigawatt scale to enterprise AI, this is the data center evolution. Capacity, not just gear. Thank you for your time.